interest இல்ல, படுத்து தூங்கு நல்லா. ஓகே, இது என்ன ரீசன் சொல்ல முடியுமா? Why it is expensive, this RAM?
Processing speed, sir.
Okay, processing speed. Okay, and then
Memory size.
memory. See, size it is less. Here it is less, 4 GB only. 4 GB 2000. This is 1024 GB, but it's just 3.6. Why? Almost this is 100 times greater, but price per 1600 rupees the different. Why? That's your technology. Okay, here see, first if you see any component, you need to think about the construction, how it is made. So here you have only a magnetic disk, but here we are playing with silicon. So which one is costly, silicon or the magnetic disk? So obviously your silicon is costlier than your magnetic disk. So that is the reason behind why this silicon chips are costlier than your magnetic disk or some other memory units. Okay, so the idea behind this is depends on the material. Here you closely watch. We have one diagram, but it gives lot and lot meaning. Okay, the bottom layer. So this axis you consider as a volume. Okay, இந்த volume வச்சுக்கோ. ஓகேவா? then இதோட time speed, எவ்வளோ டைம்ல இதை வந்து நம்ம ஆக்சஸ் பண்ண முடியும். கொஞ்சம் க்ளோஸா வாட்ச் பண்ணுங்க. மேக்னெட்டிக் டைப்போட வால்யூம் இஸ் ஹியூஜ். ஓகே, தென் போக வால்யூம், தட் இஸ் சைஸ் of the particular memory is getting reduces, but the access time, see, it is getting faster, and also the cost, this is less expensive, and going up, it is too costly. So what is the idea behind this? We have different memory units: magnetic tape, optical disk, fixed rigid disk, main memory, level 2 cache, level 1 cache registers. I hope you people know these things: main memory, optical disk, magnetic tape, and also you know registers. Can anyone tell me where these registers are available? Can anyone tell me what are the registers available in this microprocessor? As you know, what are the register names you know under this 8085? What are the register names you know under this 8085? And register la theriyum. Can you name one or two registers?
Accumulator,
flag register.
So likewise you have some register. Can you tell me what may be the size of the register? Is it in the kilobyte, or it is in the megabyte, or it is in the gigabyte, or simply a byte? What is the size of the memory? These registers. Accumulator அப்படினா எத்தனை பிட் இருக்கும்? 1 byte. It is a 1 byte. Roughly it is 1 byte. Why, sir? Why I have very lesser memory? Because fabricating any single dot in your silicon chip is costlier one. Here you can't accommodate kilo KB or MB or gigabyte or terabyte of memory inside your silicon chip or your processor. Okay, that is the reason behind we are going for the offline, nearline, online memories. The memories are external memories. These are all external memories. Internal memories sizes are very less, but the advantage of these internal memory or system memories are, please check the access time. Your register access time is in nanoseconds. You don't know about this level 1 and level 2 cache. So this one only we are going to discuss in detail in today's class. Okay. Then this main memory, this is your RAM. Okay, this is your RAM. Then these are all your external memories. Please observe, your volume is huge, but the access time is more. Why, sir? Why? Any idea? Why? Any idea? Because these components are present either inside the controller or the controller itself, or it is very, very closer to your controller. Okay, and also these memories uses same material for fabrication. Therefore, the communicate the time is very, very less as compared to your other memory devices. So that is the idea behind your memory hierarchy. Okay, so இது ரொம்ப சிம்பிளா பார்க்கணும் அப்படின்னா secondary memory, RAM, level 2 cache, level 1 cache and register. So இங்க பார்த்தனா size is less, but speed is more, cost is more. Okay, I hope this diagram is clear to you people. Okay, yes. Now what we are going to see, we are going to discuss various types of memories. Before that, in our embedded system application, on-chip memory sizes are very, very low. Okay, on-chip memory sizes are very, very low. Therefore, we need to go with some external memory. So external memory is categorized into two types, RAM and ROM. So you very well know the RAM is the one, it is a volatile. What is in by volatile and non-volatile? Any idea? Volatile and non-volatile, sir? Working memory, program memory. So program memory is the one where you will store your softwares. Working memory is the one, it is a temporary memory location. While you do, say example, you are having some set of coding. You are fetching some sensor data. The moment you fetch, you need to store the sensor value. Where you will store? Whether you will store it in the ROM or the RAM. Inga store pannuvom? Where we used to store the temporary data. Any idea? Where you will store? Whether you will store it in the ROM or RAM. Where you will store the temporary data? RAM la store pannuvom. Obviously, you will store it in the RAM. Okay. Any idea about the volatile and non-volatile? It is related to, let me give one small clue to you people. It is related to this. Any idea?
So power off panna memory erase.
Power off panna edhula memory erase agum, edhula erase agum?
RAM volatile eraser.
Volatile memory will get erased. But in non-volatile, power off ஆனாலும் எப்படி இருக்கும்? erase ஆகாம இருக்கும். Okay. So this RAM and ROM types, you people are already have studied in very detail. ROM we have a mask ROM, PROM, EROM, EPROM, E square prom or EEPROM or flash EEPROM. Okay, so these techniques and all you know. Masked ROM means it is a one-time programmable device. Once program பண்ணிட்டா manufacturer program பண்ணிட்டாருன்னா you can't alter the values. Okay, so this kind of things still we are using. So example, we are buying calculator. Casio 9MS. So அங்க ஒரு set of coding அப்படியே தான் இருக்கு. We are not going to update your calculator coding because simply I can use the masked ROM itself. Okay, that is the idea behind your masked ROM. Huge volume production, low cost. Okay, once fabricate பண்ணும்போது program பண்ணிடுவாங்க factory ல, you can't erase it. But in later stage, we require to reprogram for some time for software update. Okay, like that if you want to do something. So for the purpose, they introduced the programmable memory. Okay, that is your PROM. So PROM NSR is here if you find, here you have some array of configurations. Here, program and non-program different. If you check, you can find one fuse wire under here. So fuse wire program பண்ணாம இருக்கு, unprogrammed இருக்கும்போது அப்படியே இருக்கும். Okay, if you want to do a program, the fuse, what fuse வந்து if you fuse or not fuse, so you can cut the fuse or you can retain the fuse. Either depend பண்ணி you can store your logics. Okay, if fuse is not burned, it is logic 1. If fuse is burned, logic 0. Like that, you people can start store your informations. Okay, using some nichrome or polysilicon wires. Then we introduced erasable programmable read-only memory. Okay, erasable na idu eppdina, by giving some external voltages, you can reprogram your chips. So idu eppadi pandranga, here you can find one quartz crystal window. In the window, by passing the UV rays, you can erase the code and again you can reprogram it. This is the one kind of reprogramming technique. Okay, the next one is electrically erasable programmable read-only memory. What is the beauty here? By giving some appropriate electrical signal to this chip, you can erase the code and you can reprogram it. Okay, this is your E square ROM. Then you have a flash memory. So flash memory is the very useful technique in our embedded system. Whenever you are writing some coding and you are dumping into your Arduino, usually we are using this flash memory location. Okay, so here 1000 cycle you can perform. Okay, that means memory வந்து how much time you can write and erase என்ற cycle depend பண்ணி flash memory categorize பண்றாங்க. And also here the memory sector ஆவும் pages ஆவும் split பண்ணி வச்சிருப்பாங்க. So whenever you write something, you need to erase the whole page and you need to rewrite. Okay, so that is the technology in the flash memory. Then your RAM. RAM we have static RAM and dynamic RAM and non-volatile RAM. Sir, enna sir சொன்னீங்க? RAM நாலே வந்து volatile memory தான சொன்னீங்க. At present, there are some RAMs that will retain your data. Okay, so they எப்படி சார் retain பண்ணும்? Obviously, we need to power something. அது என்ன power பண்றது? So static RAM is this one. So static RAM la how we are going to store the information? So like this kind of some flip-flop circuits use panni we are going to store the information in the static RAM. In dynamic RAM, we are going to store the information in this capacitors. So there is one small drawback here. So capacitors charge agum. After some time, the capacitor may loses its charge. Okay, due to some leakages. So to avoid that, you need to refresh this memory frequently, or else it will lose its data. Okay, so this is the one part of your memory array. So memory array you have a number of capacitors and the MOSFET configuration. So இதுல ஒரே ஒரு செல் மட்டும் எடுத்து இங்க கொடுத்திருக்காங்க. ஓகேவா? So இங்க periodically you need to refresh the information or else it will lose its information. Okay. And the last one is the non-volatile RAM. So how we are going to get the non-volatile RAM? Very simple. Here we are going to have one battery inside the package. So the battery will take care of the volatile and non-volatile process. Okay, power off on all of it will retain the memory for some time. Okay, so this is the idea behind your memories. So these are all the functions and application where we are going to use these memories. So sir, you may ask, sir, answer if you speed or because those concepts are very well known concepts to you people. But here our main concept is to learn what is this new memory cache. I will tell you one thing. Please take your mobile phone. Please take your mobile phone. Go to File Manager. Go to File Manager and simply type cache. Can you find any folders in the name of cache? Can anyone share your mobile phone? Mobile phone konja share panna mudiyuma yaro orthanga? Please browse, go to File Manager and type cache. Type panni paaru, adu mari edha varudhan paaru. Are you getting any folder in the name of cache? Please check it in your mobile phone. Go to File Manager and browse. Type CACHE. Are you getting any folder? Yes, Sivabalan, try. Sivabalan, go to your File Manager. Yes, Sivabalan has. Type பண்ணுங்க பார்க்கலாம். CACHE. Yes, Sivabalan having some folder in the name of cache. Knowingly or unknowingly, in your day-to-day life, you people are using this memory. It's a very, very wonderful memory concept. Thank you, Sivabalan. Thank you for your immediate response. You can stop your screen. Thank you, Sivabalan. So everyone, please do this task and try to understand that in our everyday life, not only in the mobile phone, you can check it in your laptop. You can check it in your any one embedded system application. Definitely, nowadays, the modern controllers and your processors in your laptop and all uses this technology. So what is this? What is the beauty of this? Please observe. The memory management. First one is the disk storage, then virtual memory, then RAM. Before CPU, please observe, before CPU, there is a new fellow name called cache. Why, sir? Why? What is the need of this? Or else, from this diagram, you people can't tell what is the function of the cache. Just like flow path. In the flow, what is the function of the cache memory? Cache memory enna பண்ணுது? What cache memory does? Check this direction, check this direction. From this you can tell. It receives information from where? It receives information from where?
From RAM.
It receives information or the data from the RAM and it feeds into CPU. We people are thinking RAM only going to give the information to the CPU. Am I correct, sir? RAM and the data CPU but RAM காட்டிலும் கொஞ்சம் ஸ்பீடா ஒர்க் ஆகுற one more processing unit or memory unit is available, that is called as a cache memory. It is little costlier than your RAM. The size of the cache is less than your RAM. Okay, here the size may be huge, the disk storage may be huge. Okay, Why I need these kind of some intermediate components between my disk storage and CPU? Any idea? CPU கேட்கிற ஸ்பீட்ல டிஸ்க் ஸ்டோரேஜ்ல இருந்து எடுத்து கொடுக்க முடியாது. புரியுதா? ஸோ அப்ப என்ன பண்ணணும், இங்க இருக்கிற இன்ஃபர்மேஷனை இங்க கொண்டு வந்து வைக்கணும். அதுக்கப்புறம் if you don't have a cache, you can connect with RAM direct away to CPU. So these two almost similar technology. So these two people can interact in a synchronized speed. So that is the idea behind why we are introducing few blocks in between your secondary storage memory to your CPU. Okay. Now we will discuss about this fellow in detail way. Okay. Yes. Come here. Come here. What is the flow? What is the flow of data? Please check here. Memory devices running application of data and commands are transferred to RAM. So it is transferred to RAM. So processor can access the data in RAM at faster pace than the storage device. Very, very, very important. Why we are introducing these components. If you are using memory devices and if you try to communicate with CPU, very, very simple. Your CPU have many tasks to do. If CPU interacts with your memory device and wait for a long time, the efficiency of the CPU will get decreased. At that time, the CPU can do some other task. Okay, so CPU வந்து ரொம்ப எஃபிஷியண்டா இருக்கணும். ஓகேவா? ஸோ அதனால தான் என்ன பண்றாங்க, CPU கூட அதுக்கு ஈக்குவலண்ட் ஸ்பீட்ல ப்ராசஸ் பண்ற மாதிரி some memory units we are going to add in between. Okay, then here RAM can't keep with the speed of the processor. இதுக்கு மேட்ச் ஆகல. The speed is not matched with the RAM and the CPU. Therefore, they introduced the one more memory name called cache. புரிஞ்சிருச்சா சார்? ஸோ இவங்க ரெண்டுமே கம்யூனிகேட் பண்ணும்போது they can communicate with the same speed. Thereby, very, very simple, the efficiency of the CPU operation will get increased. Say example, my CPU want to copy 1 KB of data. If it do the same performance with this one, the time will be huge. But here, the time will be less. That way, after doing this process, CPU can go and do some other work. That is the idea behind why you are having these many stages in your memory. Okay. So again, cache is very, very small in size. The size of the cache is very small, but it is fast. Okay. It is placed in between your main memory and the CPU. In between the cache memory irukum. There are some situations the cache memory is even present inside your CPU. CPU kulle kuda cache memories are available. Okay. Yes. Then what is the other beauty of your cache? Cache holds the copy of your external memory. It is not a whole content, some content. Can anyone tell me why not whole content? Why some content? Can anyone tell me? Why not the whole content? இங்க இருக்கிறது எல்லாத்தையும் கொண்டு நீங்க வச்சுக்கலாம்ல. Why not whole? Why some? Any idea? The clue present in the first line. Very good. The size is very, very small as compared with your main memory. Therefore, it won't store all the information. I will tell you one simple example to you people. See, you people are studying many subjects. Embedded system, control system, power plant subject padikiro, apra subject. Like that you are studying many concepts. Okay. So this is your whole syllabus. At present, we are discussing embedded system concept. Please tell me what your main memory has, what your cache memory has at the time of 9:46 AM. The 9:46 AM cache memory la enna data irukku, main memory la enna data irukku. On brain, this is your brain. சொல்ல பார்க்கலாம் என்ன சார் இருக்கு? Any idea? Any idea? Any idea? Main memory la, main memory la, hello?
மெயின் மெமரியில எல்லா சப்ஜெக்ட் இருக்கு சார்.
You have all the subject, including embedded system, Cache memory la, whatever the content we are discussing today, that alone we are referring again and again. Very simple. Today we are discussing about only the memory. So what we used to do, நம்ம என்ன பண்ணுவோம், டக்குனு ரிகலெக்ட் பண்ணி நமக்கு தேவையானது இங்க வச்சிருப்போம். Whenever I ask, consider me as a CPU. Whenever I request something, what you will do? You will fetch from cache memory and you will answer. I am asking some other question not present here. What you will do? What you will do? What you will do? What you will do? See, I am asking something. Then you are replying, since you have some information here. This is the first case. First case. Second case. Second case. I am asking something, but it is not here. What you will do? What you will do? What you will do?
Straight from main memory.
Very good. Here it is not available. You will go back and get it from the main memory, and straight away shall you give it here, or you will store it here and then it will move here. See, I am asking something, you doesn't have it in your temporary memory location. Thereby, you are going back and getting the information from the main memory. Now you watch clearly whether straight away you will give the information to the CPU, or you will give the information to the CPU, then only you will take it from the cache. Which one is correct, sir? Which one is correct?
So through cache.
Through cache is the right answer. Avladhan sir. Cache memory function ivladhan. Okay? Very, very simple. Very, very simple. Okay? These two keywords are very, very important. These two plus this. If you remember these two lines, it is very, very easy to understand the function of this particular cell. Okay?
Sir.
Yes, sir. Yes, sir.
Sir, இங்க வந்து நம்ம RAM எங்க இருக்குன்னு காமிக்கவே இல்லை சார் அந்த பிளாக்ல.
RAM வந்து காட்டல. Your main memory is your RAM. Okay? இதுக்கு அடுத்து இருக்கிறது தான் உன்னோட ஹார்ட் டிஸ்க் something. Okay?
சரி.
நீ எங்க இருக்கிற? சட்டசபையில உட்கார்ந்துட்டு இருக்கிறியா? சந்தக்கடையில உட்கார்ந்துட்டு இருக்கிறியா? எங்கேயோ உட்கார்ந்துருக்க ரோஹித். சரி, ஓகே. தேங்க்யூ ரோஹித். சரி, நம்ம இப்ப ரோஹித் இல்ல, யாரு? ஸ்ரீஹரி. ஓகே, சரி. இப்ப now we will see, இப்ப நம்ம டிஸ்கஸ் பண்ண பாத்தீங்களா, relevant small set of, relatively small set of memory location. இங்க இருக்கிறதுல ரிலேட்டிவா ஒரு small set of location, that is active location. What is active location? Now embedded system memory concept is the active location. So அதை மட்டும் நம்ம என்ன பண்ணுவோம், we will keep here. That portion is called as working set. இந்த கீவேர்ட்ல நோட் பண்ணிக்கணும். நாளைக்கு இன்டர்வியூல போய் உட்காரும்போது வாட் இஸ் ஒர்க்கிங் செட்னு கேட்பான். அவ்வளவுதான். அவர் பாட்டுக்கு சிப்ஸ் சாப்பிட்டுட்டு இருப்பாரு, நம்ம அப்படியே வேர்த்து விறுவிறுத்து ஆன்சர் சொல்லிட்டு இருப்போம். ஓகேவா? ஸோ ஒர்க்கிங் செட்னா என்ன? அட் ப்ரெசன்ட். ரொம்ப சிம்பிள். இந்த எம்பெடட் சிஸ்டம் சப்ஜெக்ட்லாம் விட்டுரு. ஓகேவா? மொபைல் போன்ல இப்ப நிறைய அப்ளிகேஷன் இருக்கு. இப்ப எந்த அப்ளிகேஷன் பீக்ல ரன் ஆயிட்டு இருக்கு? தயவு செஞ்சு இன்ஸ்டாகிராம், வாட்ஸ்அப்னு சொல்லிடுறாரு. எது இப்ப பீக்ல இருக்குது? அபிஷியலா எது பீக்ல இருக்குது? அபிஷியலா எது பீக்ல இருக்கு?
Gmeet.
கூகுள் மீட். அப்ப இந்த கூகுள் மீட்ல நம்ம சாட் பாக்ஸ் ஏதாவது டைப் பண்றோமா? Are we responding something related to audio or sharing something? அந்த particular information என்ன பண்ணும்? Again and again we may ask. Even your code class that Google Meet link will get stored here. ஏன் திடீர்னு நெட் டிஸ்கனெக்ட் ஆயிடுச்சா நீ இதுகிட்ட போய் கேட்ப எனக்கு அந்த மீட் லிங்கை கொடு அப்படின்னு சொல்லி. So if it is stored in your cache memory, it is easy to take back and work. Okay. Can anyone tell me what is the advantage of keeping one particular fellow here and storing little information and doing the process? இது பண்றதுனால what is the advantage? What is the advantage? What is the advantage? Every time இங்க போகாம இங்கேயே நம்ம எடுக்கிறதுனால என்ன advantage?
Less time.
Very, very good. Less time. Whenever you spell less time, you think the CPU can do some other work. So na summa solite irukra some other work. Think about your mobile phone. Your mobile phone having plenty of process. Okay, நிறைய process பண்ணணும். Weather என்னன்னு கண்டுபிடிக்கணும், அப்புறம் என்ன கண்டுபிடிக்கணும், பேட்டரியோட பவர் என்னன்னு அது மெஷர் பண்ணணும். தென் நம்ம கூகுள் மீட்ல நம்ம ஷேர் பண்ற அந்த கிளிப்ஸை வந்து உனக்கு ப்ராப்பரா டெலிகாஸ்ட் பண்ணணும், பேக்ரவுண்ட் அப்ளிகேஷன்ஸ் ரன் பண்ணணும். ஹாஸ் அ மெனி டாஸ்க். ஸோ அப்போ நம்ம என்ன பண்ணக்கூடாது? we should not hold the CPU in a single function for a long time. If you do so, the performance of your entire system will get collapsed. Okay. Yes. With this idea, we will get little more depth drive. No depth or dive. Okay. But as I told you already, the same flow. First time, if you are taking something, definitely அது எங்க இருக்காது? கேட்ச்ல இருக்காது. ஸோ அப்போ என்ன பண்றோம்னா ஃபர்ஸ்ட் யூ ஆர் ரெக்வெஸ்டிங் டேட்டா. CPU request data to the cache. If data not in cache, request data from main memory. That is the second task. Then main memory will do the copy action. So it will copy the information to the cache. Then the cache will send the information to CPU. Thereby the cycle gets over. This is first cycle. Can anyone tell me, if we ask the same request again, what may be the flow? Whether it will flow from 1, 2, 3 and then 4? Next time I am asking the same relevant data. What my cache will do? Any idea? Can I get CPU request கேக்குது, cacheல இல்ல, therefore it is again giving request to the main memory. The main memory copying the information here. From there we are moving to the CPU. This is the one flow. Second time we are giving the same request. What may be the flow? Anyone please? What may be the flow? Is it will undergo the same thing again? It will undergo say 1, 2, 3, and then what it will do?
1, sir.
1, okay, 1. Then
Back to CPU.
4. 1 and 4. Think about cycle time getting reduced. Okay. Yes, we will see this one later. This is single level cache. This is multi-level cache. Enna sir, cache la nariya type irukka? Yes sir. Please observe the size. Observe the size. Level 1, level 2, level 3 cache. Size எது சார் ரொம்ப அதிகமா இருக்கு? இது அதிகமா இருக்கு. Level 3 is greater than level 2. Level 2 is greater than level 1. Can anyone tell me what may be the speed? What may be the speed? What may be the speed? Speed எப்படி இருக்கும் சார்? Speed எப்படி இருக்கும்? Level 1 speed must be greater than level 2. The level 2 speed must be greater than level 3. Okay? So these are all two kind of arrangement of your level cache. Okay. Now we will see the basic operation. We have 4 minutes. கொஞ்சம் listen பண்ணி இது ஒன்று முடிச்சுட்டு கிளம்பிடலாம். ஓகேவா? So before that, please zoom your mobile phone window and tell me name of the blocks present in front of you. குயிக்கா என்னென்ன பிளாக் எல்லாம் உங்க கண்ணுக்கு தெரியுது? குயிக்கா சொல்லு பார்க்கலாம். குயிக்கா சொல்லு பார்க்கலாம்.
CPU,
CPU,
cache controller,
cache controller, okay,
cache,
okay, then
main memory.
that's all. Thank you very much. CPU, cache controller, cache, main memory. These two are memory units. This is your processor. This is one more controller. What is the function of this controller? நான் பாருங்க தியரி கதையே எதுவும் சொல்லல. இந்த டயக்ராம் வச்சு உங்களுக்கு காட்டுறேன் பாருங்க. ஒரு ஃப்ளோவா போலாம். First, CPU gives the request to the cache controller. Cache controller go and checks in the cache controller என்ன பண்ணுது? இங்க இருந்து இங்க போய் செக் பண்ணுது. இங்க இருக்குதான். If not, it again goes to the main memory. ஓகேவா? So main memory போகுது. main memory போனோம் என்ன பண்ணுது? இங்க இருக்கிற இன்ஃபர்மேஷனை through cache controller brings to the cache. Then cache controller takes the information from the cache to through cache controller it brings to the CPU. Shall I repeat the flow once again? First, CPU gives the request. Second, cache control checks in the cache. இங்க போய் செக் பண்ணுது. Third one, if it is available, directa இங்க இருக்க டேட்டாவை cache controller will get it to the CPU here. This is the one case, first case. Second case, I'm going to change the color. Again controller checks in the cache, but this time here it is not available. Therefore, cache controller again goes to the main memory and gets the, if the informations are available here, takes and it stores in the cache, then takes from the cache through the cache controller and bring it here. That's all. It's very simple. What is the function of the cache controller? Cache controller only going to interact with your cache and main memory. Whatever the request, whatever the data you want to get it via cache controller only you can perform. Is it clear, dear students? Is it clear? This function is clear?
Yes, sir.
Sir.
Okay. Good that we will wind up here. Okay. Wait a minute. கிளம்பிராத. ஒரு சின்ன டேர்ம் சொல்லிட்டு போயிடுறேன். கொஞ்சம் உனக்கு ஈஸியா இருக்கும். இங்க பாரு. ஃபர்ஸ்ட் இங்க போறோம், இங்க பார்க்கிறோம், இங்க டேட்டா இருக்குது. எஸ் அப்படின்னா it is called catch hit. No அப்படின்னா it is called catch miss. இது ரெண்டு மட்டும் நோட் பண்ணிக்கலாமா? Thereby we will conclude the today's class. Okay, sir?
Okay, sir.
Hit and miss. No, ரொம்ப சிம்பிள். கரெக்ட் தானே? போய் செக் பண்றோம், இங்க இருந்துருச்சுன்னா ஹிட். If not, it is miss. With this, you will conclude the today's class. கொஞ்சம் எல்லாரும் வாயை திறந்து பேசணும். ரெசல்யூஷன் எடு. ஓகேவா?
சார் அடினோ ரிமெம்பர் பண்ண சொல்றீங்க சொன்னது.
கண்ணா ஆர்டினோ போர்டு கொஞ்சம் வாங்கு. ஆர்டினோல நிறைய வெர்ஷன்ஸ் இருக்குது. ஆர்டினோ யூனோ அப்படின்னு டைப் பண்ணு. ஆர்டினோ யூனோன்னு டைப் பண்ணு. டைப் பண்ணா இது மாதிரி போர்டு வரும். You have a 2 different package. This is SMD package. இந்த package இந்த ஐசியை நீ ரிமூவ் பண்ண முடியாது. this is called a DIP package, dual inline package. So இங்க இந்த ஐசியை நம்மளால ரிமூவ் பண்ணி வேற எங்கேயாவது ப்ராஜெக்ட்ல ஸ்டாண்ட் அலோனா வச்சு ஒர்க் பண்ண வைக்க முடியும். ட்ரை டு பை. பிரைஸ் கம்பேரிசன் இங்கேயே இருக்கு. 1500 rupeesக்கு இருக்கு, 550க்கு இருக்கு. மை கைண்ட் அட்வைஸ், டோன்ட் இன்வெஸ்ட் மச். ஓகே, நீ ஒரிஜினல் போட்டு 3800 இருக்கும். டோன்ட் கோ வித் தட். ஒரு லோ காஸ்ட்ல வாங்கினாலே இட் இஸ் ஓகே. ஓகே, தென் ஆர்டினோ யூஎஸ்பி கேபிள். இதுக்கு கம்யூனிகேட் பண்றது கேபிள் வேணும். ஓகேவா? கேபிள்ல 2 டைப் ஆஃப் கேபிள் இருக்கு. இது பாத்தீங்கன்னா ஜஸ்ட் 1 feet கேபிள், 30 rupees தான் இந்த கேபிள். பட் இஃப் யூ கம் டு அவர் லேப் செஷன்ஸ், நம்ம சிபியூக்கும் உன்னோட ஆர்டினோ போர்டுக்கும் சண்டை நடக்கும், லென்த் பத்தாது. ஸோ அப்போ என்ன பண்ணா, யூ நீட் டு பை சம் லென்த்தி கேபிள். இட்ஸ் அரௌண்ட் 1.5 meter. ஸோ டூ பை தீஸ் டூ. இஃப் யூ பை தீஸ் டூ, we can do plenty of projects. You can do IoT project, you can do normal embedded system project, control system ஏதாவது ப்ராஜெக்ட் பண்ணலாம், பவர் பிளான்ட்ல ஏதாவது ப்ராஜெக்ட் பண்ணலாம். நீ படிக்கிற எல்லா சப்ஜெக்டையும் இந்த சின்ன ஹார்ட்வேர் வச்சு பண்ண முடியும். கொஞ்சம் சப்போர்ட் பண்ணு. ஓகேவா? வேற ஏதாவது டவுட் இருந்தா கேளு. I will tell you few more additional components you need to buy along with this. நான் அந்த லிஸ்ட் அனுப்புறேன், கொஞ்சம் ப்ரௌஸ் பண்ணி பாருங்க. ஓகே, தேங்க்யூ வெரி மச்.